Hello and welcome back to NeetCode Easy. I'm Neha and today we have problem 12, threesome. So this problem is kind of like an advanced version of twosome part 2. If you don't know what that problem is, check out the other video. I have put the link in the description where I have mentioned how we can solve twosome part 2 problem. So in this problem, we have given an array of integers. It can have both negative and positive numbers, and our goal is to find the triplets where the sum is 0. One thing to remember is we cannot have duplicate triplets. Now before we jump into the code, let's also talk about the constraints and what's expected from our solution. So the array can have anywhere between 3 and 1000 numbers, and each number can go as low as minus 10 to the 5 and as high as 10 to the 5. And then when it comes to efficiency, we should aim for a solution that runs in big O of n square time and uses big O of 1 extra space, apart from whatever we need to store the results. So how do we solve this? First, we'll sort the array. Sorting is super helpful here because it helps us skip duplicates easily, and it allows us to use two-pointer technique to find pairs. And once the array is sorted, we will loop through each number one by one at a time. Let's call this number A, and then we look for B and C by using pointer right and left and check if the sum equals 0. Let me just show you an example. So let's take this one. So our first step will be sorting the entire array. So this looks something like this. 0, 1, 2. So this is how the array becomes after sorting. And now we start at I equals 0. At I equals 0, we have minus 4. So minus 4 is our A, minus 4. And then we look for B and C. How? We start a pointer at index 1 after A. So at index 1, we have minus 1. So we start a pointer here and another pointer at the end of the array. So at position at index 5. So at left pointer we have minus 1 and at right pointer we have 2. So now we check the sum, which equals A plus B plus C. So here our B is left pointer and C is right pointer. So minus 4 minus 1 plus 2, which equals minus 3. So which is less than 0. So if it's less than 0, that means it's too small. So we move left pointer one step forward. So now our pointer will point toward, instead of minus 1, it will point towards 0. So here everything will be same. A will be minus 4. Left will change here. So left pointer now will have 0 and right will remain same. So now our sum becomes minus 4 plus 0 plus 2. And here we have minus 2, which is still less than 0. So again, we move our pointer, left pointer, one step forward. So now left becomes 1 and right is same. So our sum is equals minus 4 plus 1 plus 2, which equals -1. It's still too small. So here we need to change I, because left will be like greater or equals, right? And we don't have any numbers here to move forward, so we change I from 0 to 1. So now our A is -1. So here our left pointer will have again -1 and right pointer will be 2. So here left is -1, right is 2. So our sum becomes -1, -1, -2, and plus 2, 0, which is exactly what we have. We found our first pair, -1, -1, comma 2. And then we move to I equals 2. So at I equals 2, our A becomes -1. And our left pointer starts at 0 and right will remain same. So left equals 0 and right pointer is equals 2. So the sum is equal -1 plus 0 plus 2 equals 1, which is greater. So we move our right pointer inward, one step inward. So left will be same. Our right will change from 2 to 1. Now our sum is equal to -1 plus 0 plus 1, which is exactly what we are aiming for, 0. So now we have another triplet, -1, 0, 1. And as you can see, the output is exactly same, those triplets, -1, -1, 2, and -1, 0, 1. So now we understand how we are planning to proceed. Let's convert this idea into code. I'll comment these out to make some space. So as always, we are going to use Python here. And first, we need to sort our input array, as it will be easier for us to avoid duplicates and apply two-pointer technique. So nums.sort, function sort is going to sort the entire input array. And then we initiate an empty list where we will store our valid 3-sum triplets. So result equals an empty list. Now we loop through each number in nums, considering it as the first number of the triplet. So for I, comma A in enumerate nums. So here we check if the number is the same as the previous number, we skip it to avoid duplicate triplets. So if I is greater than 0 and A equals nums I minus 1. Sorry. So if this condition is true, we continue, and then we set our left pointer just after the current index I. So here we initiate our left pointer, which is gonna start after I plus 1, and the right pointer will start at the end. So we'll subtract 1 from the size of the array, and that's how we get our pointer at the end of the array. We initiate a while loop to keep searching as long as the left pointer is less than the right pointer. So while left is less than right, so while this statement is true, we calculate the sum of the triplet. 3sum, let's call it 3sum, equals a plus nums left plus nums right. And then we are going to check if sum is too big. If it's too big, decrease right pointer to reduce the sum. If it's too small, we increase left pointer to increase the sum. And if it equals 0, we have found our triplets. So let's start checking one by one. If 3sum is greater than 0 and if 3sum is greater than 0, then we need to move right pointer inward. And if 3sum is less than 0, that means we need to increase our sum. So we move left pointer forward. So elif, otherwise we will append those triplets to the result. So result.append a, we are going to append a pointer, the number at pointer left and the number at pointer right. So nums left, nums right. And then we move our left pointer forward to look for the next potential pair. So left plus equals 1. Now, to skip over any duplicates for the left pointer to avoid repeating triplets, we are going to use a while loop. And here we check if left is less than right and nums left is equals nums left minus 1. If that's true, we move left pointer one step forward. This way we are going to avoid duplicates. And finally, once we check everything, we return our result. And that's it. Our code is ready to test. Let's run this to make sure we don't have any error. Yeah, the test cases are passed. That means our code is working well. It's working well. And if we see carefully, here we first use sorting technique, and sorting takes big O of n log n. So it takes big O of n log n time. Then the loop runs n times. Inside that loop, we are using 2 pointer, which together runs in big O of n time. So our total efficiency becomes big O n log n plus big O of n, which equals big O of n to the power 2, big O n square. So overall, this gives us big O of n squared, which matches what the problem recommends. In terms of space, apart from the output list, we have just used few pointers, so the extra space is basically big O of 1. And that's the idea behind threesome. So the array used 2 pointers, skip duplicates, and you've got a clean and efficient solution. In the next video, we'll solve problem 13, container with most water, another 2-pointer problem. So stay tuned and I will see you in the next one. Bye bye.